building POCs, we've seen that over and over again, right? Now, how to build actual production code, that's another story, because you have to keep balancing speed with quality. It's not enough to build something that works. It's something that needs to, when you give ownership, when you provide the space to the team to be themselves, that's when people thrive. There are, in my opinion, there are mainly two reasons for which we work. The first one is money, but the second is the way that we are building software right now have dramatically changed, because we've been building software with the mindset of building to maintain. Yeah. That's not the case anymore. Now we are building to a
Hello and welcome to the AI and ML conversations with myself, Javor Botev. Today, I'm very excited to have Carmen Herrera with me. Carmen, hello. Welcome to the podcast.
Hello. Yeah, thank you so much for having me, Javor. I'm super excited to be here today.
Yeah, the pleasure is all mine. Well, I wanted to give our listeners a little bit of your very interesting background. So Carmen is currently a director of data science at Typeform. It's probably a company that many of our listeners would be familiar with. I certainly knew it, and I've used it in the past. But for those who don't know, it's essentially web form builder. And I know that now you've been doing some very exciting things with AI that I'm sure we'll touch upon in the conversation in a little bit. In Typeform, Carmen has spent a number of years starting as a senior data scientist and obviously rising through the ranks. Before Typeform, she led the data science function at ECL Faceit, which is a leading esports and video game entertainment company. She was also a lead data scientist in Mango, the fashion retailer, very popular in Europe and one of my favorite fashion brands, actually.
Yeah, me too.
And yeah, and last but definitely not least, she holds a PhD in physical oceanography. Yeah, how cool is that? So very interesting profile, and very excited to have you here, Carmen, as I said. And yeah, well, I wanted to start with the most obvious question, which is, how did you end up doing this PhD in physical oceanography? Yeah, tell me all about it. How did you decide to do this? I'll also ask you, of course, how you transitioned to data science, and maybe if there were any useful learnings in the PhD. I'm sure probably there were quite a few. So yeah, I'm very curious to hear that story.
Yeah, absolutely. So my background goes back to physics. So I hold a bachelor in physics, and I studied physics because I wanted to understand how things worked. Right? I had this very keen mind and trying to understand how the earth worked and the universe, and I was eager to get answers. And I think physics gave me that sense of trying to understand things. And then what I realized is that I wanted to know more. So this is why I pursued the PhD back in the day. So a master's and then a PhD in something that was a passion of mine, which was the ocean. So during my PhD, I did it at the Marine Science Institute in Barcelona, in Spain. And then I also went for research stay in the UCSB in California, in the University of California, Santa Barbara. It was great to have the opportunity to be there for a while as well. And basically what I was doing there is trying to understand how the ocean affected the climate in very long time scales. Sounds amazing, right? Sounds super interesting. I loved it. But what I did love the most is to build models to use data to answer questions. That's where I started just, building different data modeling and building pipelines and just trying to, explain with 15 degrees the different with different equations how to explain how things happen and what was a causality of things and so on. So it was a great learning opportunity for me in that moment. I also interacted with very, very big chunks of data. So I also learned like all the data cleaning, data mining, and all the different processing techniques. It was very interesting. And there was a moment when I was finishing my PhD, starting a postdoc actually, that I realized that what I really loved was to get answers from the data. But I also like to eat. And being in the academia, sometimes, it's tough. It's difficult. It's not easy to get an actual, payload at the payslip at the end of the month. That's when I got some friends back in the day, and there was some conversations around the internet about data science and big data. It was like it started to grow at that point, and I felt like, let me just dig a little bit more into that. And that's when I decided to just drop the academia. It was like, been there, done that, check. Now let's move into bringing real impact. Because what I was feeling is that I'm building things, right? I'm building models, I'm building systems, I'm answering questions. So what? I'm answering how, I don't know, 300,000 years ago, the Earth was working. Fantastic, but who is helping right now? Like, that is not something that can have a real impact, right? And I was really missing that bit. So yeah, that's a moment when my mindset changed, and I said, I want to bring real impact, and I want to have a stable job, and I want to do it using data. So I started as a junior data scientist back in the day in a small consultancy firm in Barcelona, the research facility actually. So kind of in between, right? Because we had it's called Eureka, and we had some public projects. So basically more kind of academic projects, while also having third-party clients we have to build systems for. So it was kind of in between the two. And that's where I got exposure to many different tools, many different areas, and I started just growing into the data science world on there.
Nice. Okay, so you mentioned a few things that I actually want to dig a little bit deeper into. One thing you said was that you were focused on long-term modeling. So would it be correct that you were trying to find the causes for, I guess some changes in the, I don't know what's the proper term, in the shape of the Earth or the ocean or something like this? It was was it in a causal setting? So for two questions. One is, how long-term were the questions that you were asking and trying to answer with modeling? And second, was it a causal study?
It wasn't strictly causal. So basically what I did was, we had data points from the past, right? And you got data points for how CO2 was like 100,000 years ago from the ice in Antarctica. So basically you can dig a hole in the ice and get down deep a few meters, and what you're going to find is ice that was actually built in hundreds of thousands of years ago. And in that ice, you're going to find bubbles of air. And you can actually analyze those bubbles and get the actual CO2 from the atmosphere 100,000 years ago. So what I did was get that data. That's common. That's public information, right? Like, we had those data sets. It was from 300,000 years ago up until now. And what I did was create a model try to create a model that was able to reproduce that signal. And what I did in order to do that was build relaxation models. So different equations that were able to explain, using, I think it was 15 variables, how different parameters of the ocean potentially provided as an output that signal. So what I had basically was a phase space of 15 parameters, 15 dimensions, which I had to, using genetic algorithms, I had to optimize and find the optimal value for each of those 15 parameters to get to the output that I wanted, which is the minimum distance between the two curves. Maybe it's too much.
No. That's perfect for myself personally, and I think for a number of our visitors that would be super interesting. That's one of the reasons for this podcast, to go into depth into such questions and such modeling approaches. Especially if I'm so impressed by the age of these data points, thousands of years ago. That's so interesting.
But it's fascinating because actually I was using this 300,000, but there was other experimental data points that we had from 1 million years ago. It's absolutely mind blowing. And what is not funny, but what I found more interesting is to run the algorithm back in that day. This was like 2011, maybe maybe 12. So it's not that long ago, right? Like what, 15 years ago, 12, 13 years ago, the model was working, so that the algorithm was working for 3 weeks. So every time I put it to run, it took 3 weeks to get me the actual value that I needed. So it was mind blowing.
Crazy. And just out of curiosity, what software packages did you use for to model these things?
So at the beginning, I started working on Mathematica. So it was like it's a model, a language that we use in that it was used for scientific programming. And then I switched to MATLAB. So I built everything back in the day on MATLAB. Yes, which is not ideal because MATLAB at that time had several packages for multi-thread, so to be able to parallelize some computing. But of course, they didn't have the equipment to do that. Just, it was all serialized, and sometimes I was able to use the 8 cores of the computer that I got in order to parallelize some parts of the algorithm. But it was different era, I would say.
Yeah, definitely. And I've also used MATLAB when I worked in finance, and I remember I was so much more difficult to find information back then. And MATLAB is actually don't know if it still exists, but back then it was a proprietary software. You had to pay for it, and it was all very kind of a closed environment. It's not like nowadays with Python packages and whatnot. Everything is open source.
There was no community. There was no community at all. This is why I think many researchers end up migrating to R back in the day. But MATLAB was a proprietary software. Actually, sometimes, inside the company, we had problems to get all the licenses that we needed. So it was an easy situation, no? And definitely not community, which is something that I love nowadays, that you have open software and you can simply have amazing communities around you that help you out, especially when building something new.
Yeah. Something else that caught my attention while you were speaking is that you were looking for practical impact. And I hear this desire a lot, and I also see it in myself. That's one reason why I also went for a bit more practical career choice after my studies. Related to this, when I was looking at your profile before the conversation now, I found that you have a very goal-oriented mindset, I think, and you are always trying to relate your data work on what moves the needle, on the final goal. I noticed that, for instance, when you were working at Mango, you were building models that were optimizing the prices and otherwise helping the bottom line, optimizing the profits of the company. Are there some interesting stories that you can share from that perspective?
Yeah, it was a very interesting and challenging time back in the day in Mango. We had this amazing opportunity because when I joined, it was a very small team we were called Advanced Analytics, I think, or Data Analytics. No, Advanced Analytics, yes. So basically, we were the Mango, I think all retailers in general, but it's like more old-fashioned type of industry where things are taken slowly and data is mainly informative, but not really decision making, right? Or at least it was back in the day. Things have changed completely since then, but it was the beginning of pushing forward predictive modeling into the business. So we had to prove the value before anything, right? So what we did was build a POC in order to prove if we were able to actually optimize prices or not. And then one of the things that I found is that sometimes first of all, you need to prove the value. And second, you need to convince people to have trust in those data models. So that doesn't come from scratch, I will say. That doesn't come just in a free environment. You have to show and have people believe that actually that is true. So what we did was build a POC and then we did an experiment. So we did an experiment, an A/B test to show different, the values that the model was predicting with the prices that we had. So we can prove if things were working or not. This is why I think experimentation is extremely important in this environment. And also you need to explain what a model is. Not everyone understands what a model is. I'm pretty sure that you've heard this many times. You've also seen these and suffered this yourself. But sometimes business just thinks that you have like this magic wand and you're Harry Potter and you can make some magic and just create some data. And if they do believe that, they are not going to trust that. they're not going to trust the outcomes of the project. So what I did was we built this very quick POC. We did the experiments. And what we also did was making sure that we weren't using any fancy, difficult models that we know it was going to be way better. If I use a neural network to predict like an LSTM, right? Like something like that to predict prices, it will be like accuracy will be better. I'm sure of it. I don't have any clue, any doubt about that. But what we did instead is just building a decision tree and just proving to people these are the signals that is actually driving the prices. Let's work together with the business into getting those signals right. And over those iterations, people started to embrace more and more the data, because how many times we've seen projects, models just being in production and no one actually using them. So the only way to have a real impact is for people to use the data. You have to create that trust. It's a matter of building things that actually matter, that people need, but they also can trust.
Okay, and then I guess you had a lot of stakeholders which were not technical people. I found in my career that one of the big challenges is to convince people who are not technical and data minded in the values of your machine learning and data solutions. So was that a challenge back then? Or maybe a bit more generally, you don't have to speak specifically about this situation, but a bit more generally.
No, but I think it's a perfect example, right? So we had to work hard on trust, show the value, prove the value, and explainability. It was a must back in the day. In many other projects as well, but in that particular project was extremely important. Once you've proved the value, once you are able to explain to people and people start embracing and trusting the outcomes of the model, and they start using it, then it's when you can scale. That was a moment where I remember back in the day, it was crazy when I think about it, right? But it was me waking up at 5 a.m. and putting things to run and just doing things manually, because it was all POC based, right? Like we just wanted to see if things worked. So we didn't have time to build actual systems and, jobs. And no, it's like just run it, prove it, and manually taking things. And once we saw that things actually worked, then is when we moved into a production environment where it was a massive infrastructure change. We weren't ready for having big data, right, at that time. So, but it's a massive amount of data when you start thinking about pricing for every single different prices. Like we built this, like the way that the model worked back in this pricing optimization was, we created a demand forecasting model to predict the demand based on price. And then what we did was create a huge matrix of all the possible price points for a model, an item to have for every single week of the sales time, the clearance sales. Then calculate what was the remaining the stock that was left after that, and account for that cost as well. So it was like, how can we optimize based on all this space of possible prices? What is the actual optimal one based on the stock that will be left and the amount of revenue that is going to come from the sales minus what is going to be left? So it was massive. We were optimizing for, I cannot even remember, but it was like 3,000 items, 8 weeks, 15 different countries. I don't know. It starts growing, right?
Yeah.
So we had to create, the infrastructure for that. So we created all the jobs were written in Spark. Everything was written from Databricks and the data lake back in the day. So we were starting storing everything in the data lake. We created the actual data lake back in the day. And then we also created like a front end for the different PMs to be able to consume the data directly. So create the simulations themselves of what kind of scenarios I wanted to run. Do I want to run a more aggressive price scenario? Do I want to be more conservative, or just so they can be autonomous into the decision making? So we were providing the data for them to take the decisions, not automating everything, because there are business decisions that you cannot automate. what we can automate is having all the scenarios for them so they can actually take the decisions with the data that they actually need. And I've been out of the company for quite some time, but if I'm not mistaken, that project still it continues, and they have been improving it significantly since then. But it was all the beginning. It was how everything started.
That sounds very interesting. And to be fair, building the data lakes, I don't know, that was at least 5-10 years ago, I guess. That sounds kind of advanced, because that was not very, I think it was an up and coming topic back then, but it was certainly not something established and just simple, easy things that you can do.
It wasn't. No, it was. We were a little bit like just discovering things as it was. But I was very lucky to work with such an amazing team back in the day. I remember working with an architect that he was very, very good, and he was super helpful. And the Databricks team back in that moment also as well, they were extremely helpful. And imagine mixing all of that with COVID.
Yes. Oh yeah, of course. Was it during COVID when you were part of them? Okay. Oh wow.
Yes, everything shut down. We were in lockdown. The company shut down, but they left, I think it was like 5 or 10 projects in the whole company, in the whole world, that they wanted to continue working on, and one of them was mine. So I was supposed to have I'm trying to remember, it was like a 16 or 17 people team, and then at the end it was like 3 or 4 of us just working remotely from home, trying to survive. I had a 2-year-old daughter at home as well at that time. It was like madness all over the place. I learned tons.
Yeah.
I'm just recall now that actually, because we were building the new systems, we didn't even have Git in our pipelines. So we couldn't even commit our code. So I was actually reviewing the code manually from my team and ensuring that we were just, because I split it between different team members, the different pipelines and so on. So I was the one just orchestrating everything myself, and I had to review everyone's code to ensure that they weren't changing anything. It was madness. Now I'm remembering. Oh wow.
Wow.
Man, I could not live without Git nowadays. Like GitLab, GitHub, whatever you use.
Yeah, of course. When I worked in finance in the first years, we didn't have a solution like Git to keep track of the versions of our code. So that was the case for you as well in the early days?
So the thing is, we had version control. I think it was GitLab back in the day. But because we were connecting things, so we have some actions as well planned, but because we were building new infrastructure and new things, they were making changes there. So it wasn't reliable. I don't know. It was a matter of few days, I think. But it was like very painful. I remember those days as a very painful thing of having to build software without actually having a full version control. I think it was because initially we built things internally using Databricks notebooks as well. And there was no version control there. And then we had to export things and put it into the actual software that we were building. So it was like, moving things around. I don't know, I cannot even remember, but yeah. Good old times.
On that note, software engineering practices. So your studies were physics, and of course you did a more technical PhD, and you worked as a data scientist. But there is no, I think oftentimes for data scientists, it's not really clear how they should obtain their software engineering skills and how they should improve them. So how did you go about doing that?
That is an excellent call. So yes, my background is on physics. So I never learned properly software engineering, right? I'm not computer software, computer engineer. I didn't come from computer science. So it's a different kind of background. So I never learned how to properly code, let's say. And the way that I learned, it's through doing. And ensuring I'm always like to, read and try to understand how I can improve over time. So this is how I learned. And I'm pretty sure that it's not the best way to do it. I think nowadays, if I had to start over, my recommendation will be just get yourself into a good Python course and learn how to properly code things. That would definitely be useful. In my case, and I think we've seen I've seen this many times with people coming from a more scientific background that I wasn't the best coder, to be honest. And my code wasn't optimal, but it always did what I wanted it to do. And if at some point I needed to ask for help to optimize my code, I just asked. Like, I wasn't afraid to do so. One of the things that it was important to me is that I understood what I was doing and I knew what I wanted it to look like. I think that barrier nowadays, it's been maybe not completely gone, but significantly gone. Now we have code assistants, right? And that is something that has changed the way that we think. But we need to understand what we are doing and what we expect to see and what we expect to build. And that is the missing or the key piece that we need.
Yeah. On understanding, what are your thoughts about understanding the statistical and machine learning models and maybe even LLMs? Is this something that you feel like you should do, perhaps as a scientist, given your background? Or how do you feel about this? Because I think software is very, I think it's quite straightforward. You have some functions calling other functions, variables, etc. So it's easier to wrap your head around software, around code, than it is to wrap your head around machine learning model. Why the predictions it makes are like this. Why is this variable important and not that other variable? So what are your thoughts on understanding machine learning models?
I think it really depends on the type of work that you want to do, right? You don't have to be a machine learning engineer to be able to call an endpoint or to use a vector database. But if you really need to do something that is meaningful with them, you need to understand the fundamental, basic underlying systems. So if you really want to build models, you need to understand the fundamentals. You need to understand the statistics. You need to understand how a probabilistic model works. What does it mean to have, a feature importance? Feature importance is not causality or anything like that, but you need to understand all of those nuances behind it in order to actually use it in a way that it's meaningful and it will have an impact. Nowadays, I think we have to make the distinction, and sometimes that is difficult, right? Nowadays, we have amazing, the amazing opportunity to build software using tools that it was not even remotely possible a few years ago. Everyone can call OpenAI API. Everyone can build an LLM system, and iterate on that. But if you really want to build systems to last, you need to have someone that really understands the actual behavior of an LLM, the probabilistic behavior, the non-deterministic way of thinking, and ensure that you implement your software in a way that accomplishes that. We can move towards that space if you want, or we can stay on this path, but this is why I think potentially the way that we are building software right now have dramatically changed. Because we've been building software with the mindset of building to maintain. A few years ago, you build some software and you maintain it, but it's there, right? Like, the outcomes, how it's going to behave.
Yeah.
That's not the case anymore. Now we are building to evolve. So you build things and you need to add evaluations on it. Those evaluations, it's not like the old monitoring. It's part of the product itself, because the systems evolve, customers evolve, needs evolve. So you need to keep iterating over and over again over those systems. So it's like this kind of mindset from going from deterministic to non-deterministic. That's a huge change.
Yeah. That's a very interesting point, and I will make a note to discuss it in a little bit, because it's also something that, of course, I've been noticing. And I guess that's related to your work at the Typeform. So why don't we move to Typeform? How did you progress in that company? Because you've been there for a number of years, and you managed to progress from senior data scientist to your current director role. So if you can share some useful tips on how our viewers, for instance, who might be interested in career progression could use in their own careers, some interesting stories from your time at Typeform. I'd be very keen to learn.
Absolutely. So I joined Typeform back in the day. and there are many stories that we can share, right? But when I joined Typeform, I was a senior data scientist, and I was working for the customer experience team. So I was building recommender models for our support team, so they can understand who were they talking to on a live chat, for instance, and they can actually provide useful recommendations to our customers. So understanding who the person that they were talking to, and how can they really help them. And then the leadership, and back in that moment, I was part of this. We were based on squads, so it was like a small data science team inside each of the different product teams, let's say. Then I started my leadership journey on managing the machine learning platform team, so basically machine learning engineering. And then eventually, through several reorganizations and several changes, I ended up with the data science division. So both data science and machine learning as well. And that also meant that we had to do a restructuring of the company, so several reductions. So we ended up being a more centralized team. I think data teams can, in my experience, normally keep changing between centralized and embedded and centralized. You keep moving between the two models.
Yeah.
I think depending on the needs of the company, one works better than the other, and sometimes you need to keep iterating on. For the type of the size of the company, the needs of the company, having a centralized team worked way better because we were creating these silos. There was no shared good practices and so on. This is something that has always been like an obsession of mine, like, following good practices and making sure that people have standards, that people can talk to each other because they had the same type of work to work on, having shared libraries, shared systems, and so on and so forth. So it was a great, reshaping in that sense. And we were able to start providing more and more quality because we also, as we were maturing, we also had these very distinguished data engineering, data analytics, and data science functions. So we can provide different levels of, through the data lifecycle, I will say, different levels of support to the business. Because in the end, it's what the business needs is what actually needs to, that's the driving force for how the data teams should be structured and how they should work.
Yeah. Interesting. And how big approximately is Typeform, and how big is the data teams or data team?
Right now, we are around 300 employees, more or less. And the data team is around 20 something, more or less.
Yeah.
Yeah, kind of. I will say we are in a very good shape right now. It's an amazing moment for the data team because we've got an amazing leader, right? We've got Mike Angelo, who is one of the best leaders that we could possibly have. He's a VP of data, and he's been able to move our org from a more reactive, which is more common, right? Like the business asks something and you just provide the data, to a more proactive approach where we are able to provide the data to the business so they can take the decisions. And that is an amazing situation that we have right now. So I was managing, the data science division back in the day. And also at that point in time, I started managing the data analytics as well. So it was a moment that, I was a little bit doing kind of everything on my own. And the interesting thing, and I'm sharing this with total confidence, I realized that I started to be burnout. Like quite literally, there is always a moment in everyone's career where either you take the people path or the technical path, where the amount of things that are on your plate are not, like, you don't have enough hours during the day to actually do that. So you have to learn how to prioritize. You have to learn how to say no, how to, manage the expectations, and how to let go of some things that you simply need to delegate or simply decline. So at that point, I was really starting to be burnt out, and I felt like I've always thought that as leaders, a leader, first of all, a leader is, everyone can be a leader. You don't need a title to be a leader, right? Let's be that clear. I'm no one's boss. Like that's not my intention at all. My role as a manager or as a director is to enable people so they can do their best job. So I work for them and not the other way around.
Yeah.
So as a leader, the way that I see it is I need to empower my teams. I need to be a role model for them. And there was a time when I was starting to be really burnt out, and I felt like I was not going to be a role model for them. I needed to go. I needed to
Yeah.
get some fresh air. It was, I had a long tenure or significant tenure at Typeform.
Mm.
So I decided I quit. I decided to go. And this is when I joined EFG, so ESL Faces Group. That was 2024, to work with this amazing set of people and amazing leadership on the esports world,
Mm.
to work on the data science team and to start building, these functioning capabilities inside the company. But then in August 2025, so last year, we were in touch with Typeform, and they had this vision of becoming AI native. New leadership came in and so on. And I had this amazing opportunity to come back as a director of data science or AI engineering. And it was when, I've always held Typeform very, very dear to my heart. And I was able to just, not be born out
Yeah.
anymore. And the setup was really interesting. The leadership have come in, as I said, and I could just focus on the data science and more than data science, AI engineering. So basically we are
Mm.
doing like the actual work of building the AI features with the product teams. And that's when I decided to come back. Yeah.
That's very interesting. I made some notes that I would like to go in a little bit deeper into. Um, One of the things is, well, probably the one of the most important things is indeed managing your own career in a way that doesn't harm your health, so that you can continue to perform well in a number of years to come. Um, so, what do you think are perhaps some good practices that, as an individual, people can try to stay healthy both mentally and physically? And then also, as an organization, what kind of a culture perhaps you need to create to foster this well being?
Love that. It really depends, right? Because what works for me might not work for you. So it's
Mm,
not like a perfect recipe. But what I found out is that, at least for the teams that I've managed over time, when you give ownership, when you provide the space to the team to be themselves, that's
mhm,
when people thrive. There
mm.
are, in my opinion, there are mainly two reasons for which we work. The first one is money. I need to eat. I need to pay my bills. Like if I was
Fair
rich,
enough.
most likely, I will be doing something else. But the second is personal growth. So you need to feel that you are growing, that you're having more than just a job. There are
Mhm.
some times in your career that you cannot choose. It's just, it's what you have. And the second option, the personal growth and so on, it's just, you have to forget about that. But in general, what I found out is that you can survive just with one of the two options. But if you want to really stay and really be healthy, you need both. You need to have
Mm.
a place where you feel that you are earning what you deserve for the work that you are doing, and also a place that really values you as an individual and that you are growing your career. It can be more a personal development, or it can be more a career development, but you have to be growing. You have to get more than just a pay slip.
Mm.
So if you provide an environment where people can thrive, when people can feel the ownership, when people can learn, those people are going to stay. And if you, as a leader, you help protect them, you help give them the room to actually do the job. So if you are an actual enabler of that team, not just by putting pressure, but to giving them room to breathe and understand why they are building something, to connect the dots for them so they don't have to
Yeah.
do that hard job of understanding, what am I doing today? Like,
Yeah.
what is this? Like all the chaos, all companies have, like all these different threads and noise and things. If you provide clarity to the teams and space to grow, they're going to thrive. I'm 100% sure of it.
And can it be sometimes that the people push themselves too far, like they don't know when they should say, okay, I'm doing a great job, I shouldn't just do too much of this. Is this something that you're seeing? Sometimes people get too excited about their work, and maybe they want to spend all night coding or something to solve a problem, should they be doing this or not? And I know it's that tough question, but
It's
what are
a
your
tough
thoughts?
one. I would say that's a hot take, right? That's a real hot take. In my experience, you can like I always say to my teams, I'm not your mom. I'm not gonna tell you when you have to code or when you have to, build that pipeline or whatever. I'm not gonna be there controlling you. We work in a remote environment, so I'm gonna trust you. I'm gonna trust you that you are a grown up. But that's not sustainable. So if you are keen to do something and you do it out of passion, awesome. Like I will make sure that you do so over some guardrails that are safe for you and safe for the company, but especially safe for you. But if you want to do it, you're going to do it, right? If you want to code at 3 a.m., there's no way that I'm going to like prevent you to do so. But that's not sustainable over time. So if you keep pushing yourself, at some point your mind is going to be fried. So you are going to not be able to deliver. And that is when the problem that's a problem on the long run, right? So I love this concept of playing the infinite game by Simon Sinek. So you have to think about the long run. Can you maintain that over time? It's sometimes we've all worked in very hard sprints sometimes, right? Like sometimes we all had to work over a weekend or late at night, or I've got a delivery to make and I have to do it, right? But can I do it every single day? Can I do it for a month? Can I do it for a year? No, you can't. Some point you break. So is that sustainable over time? Not really. So as a manager, as a leader of my team, if I see a pattern happening, my job is to prevent it. My job is to ensure that the teams are healthy and safe so they can keep delivering at a high pace. Let's be honest. Like we are not here just, we have to deliver at a high pace, but in a way that it's sustainable. And that means that sometimes it's going to be like more high capacity, sometimes it's going to be a lower capacity, but it needs to be sustainable over time. That's the key part. And if you think about it, the way that I always approach it is I can burn people up. I can burn people out. I can just, give my team tasks to do for 60, 70 hours a week. Yeah. But at some point they're going to quit. And that is going to create a problem for me. Because if I'm being extremely honest here, I am being selfish when I'm protecting the team. Because what I'm doing is ensuring that the team will stay and they will be happy and they will keep growing and they will keep delivering without creating the problem of someone leaving creates a huge knowledge gap. And to ramp up someone, it's not the time that you take to hire someone else. It's the time that someone takes to actually get on board and get all that context. That takes years. Yeah. So longer tenures are extremely better to the company than not people just burning out, even if for a time they work for, I don't know, 50, 60 hours a week, whatever.
Yeah, great points. I have to say I agree with pretty much everything, especially on the last bit. I think many companies underestimate how much they lose when somebody leaves the company, especially if that person is a good performer, because there's so much understanding of the company that goes with him. And how long is it going? Like, it's going to take months to hire someone to replace that person. Then it's going to take months for this person to ramp up, to understand all the product and all the people, all the departments, etc., etc. So indeed, I think it's in pretty much everybody's best interest, both the employer and the employees, to have a sustainable work schedule and work rhythm. So that in the long term, the output is, let's say, maximized, to use a statistical term.
Exactly. You want to maximize the outcomes, right? So you have to make sure that you balanced out all the different scenarios there, and you optimize for them. And I'm saying this when I was, I've always struggled to say no. I've always struggled to put myself first among others and to put myself first among my job. Like I deeply love my job, and I'm the first one to stay late if needed and work over the weekend if needed, and not being able to properly disconnect. So I learned that the hard way, let's say. Sometimes we have to actually feel it. to understand what it means to be there and to help others on that journey as well.
Yeah, 100%. Okay, so you mentioned that you were, I think, hired back in Typeform because the company had been planning this AI revamp. And I know a lot of companies are doing such AI revamps, and a lot of companies are saying very, let's say, ambitious things. And they say, yeah, we're going to turn around the world with by adding LLM to our capabilities. But
Yes.
what's the story in Typeform? Kind of, yeah, what made you, well, from a technical perspective, what are the interesting things that Typeform is doing with LLMs?
Yeah, love that. So look, in Typeform, we are building forms and we are also building flows, right? So the people can get the best out of the data collection interactions with their customers. So the way that we approach it is we don't need AI. Like what we need is to solve a customer problem. And if that customer problem can be solved with a business rule model, let's go with the business rule model. If that customer problem can be solved with regression, let's go for the regression. But if we can build a system that solve a big customer problem and we need AI, let's do it with AI. And that to me is a key part, right? Because nowadays everyone can, we said that before, everyone can call OpenAI API, right? Everyone can just connect to build this very simple chat interface and connect an LLM behind the scenes and just put something to talk to a customer. But is it actually solving any customer problem, or is it creating fiction and losing trust of your customers? That is a big difference over there. So we start with the customer problem. And the way that we have been doing it is we are building products that benefits the most from AI because it helps solve our customers a problem that they are having in the most reliable and in the fastest possible way. We have, for instance, put AI into the creator's experience. So now people can create a form without really knowing how to create a form. In natural language, you ask for what you need. I want to create a form for doing this, this, and this. And it automatically creates you with the type of questions that you need, with the type of blocks, with all the knowledge that you will take time to build. Now, in a matter of minutes, it's done. Imagine you have to translate a form that you already have. In the past, it will have taken time. Like you have to go question by duplicate the form and question by question. Now you can just simply say, translate this into Spanish, and it automatically transform it to Spanish. That is amazing from a customer perspective, and that's exactly why AI is useful. Having something that is not useful, why do you need that? We have the creator speed, and we also have, for instance, on the insights, how to get answers from the data you are collecting. With the use of AI, you can get summaries, you can get answers, you can get just, all the information that you need from your answers. With a few clicks and a few minutes, you can get all the answers, right? That is solving an actual problem. And this is why AI is important and it makes a difference. It's not just a hype thing that we all are doing now.
Yeah.
You need to focus on real outcomes and solving real problems.
And how about using AI in your IDE, while you're writing code? I think that's... So there are a couple of angles on this, just strictly from software engineering perspective, I think can really speed you up. For building machine learning models, it's not so useful because machine learning models, take a lot, the challenge is not necessarily with writing the code, but it's more on feature engineering, data cleaning, stuff like this. And then I guess on the third part is, how LLMs are integrated into software, and perhaps evals are introduced to make sure that the LLM solutions actually work and deliver what they should be delivering. Yeah, so what are your thoughts on these topics?
So many things to unpack there.
Yeah.
Let's begin by having AI assistant in the coding. For software engineering, I agree. I think it's like, let's be honest, it's super helpful. It's extremely helpful. Like sometimes, especially for me, like I don't code in day-to-day basis nowadays, right? It's so great. Like I know what I want. So I can just ask it to build it, right? But even for people that are not technical, it will help them understand better the complexity of what it means to build something. So nowadays, building POCs, nowadays, just understanding the code, nowadays, just understanding databases, that is extremely helpful on those areas. Building software now, I think, it has been extremely helpful as well because it has to speed up your process. And for machine learning, yeah, maybe you have to think still, right? You have to think why are you building and how it works and so on. But it has to speed up, how to do stuff. I will say that depending on the type of, like, for instance, in the past, I was very used to work with a particular set of libraries. So if I got an assistant that built it in another library, I would be like super picky about it. Like, no. I want you to have to use scikit-learn, blah, 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 whatever.
Yeah.
Maybe people that start now, they are not going to be that picky because it's not going to matter strictly what is the actual functions or methods that you use or algorithms, but it's about the outcome. So building POCs, we've seen that over and over again, right? Like building quick things and fast things, it's absolutely amazing and super fast. Now, how to build actual production code, that's another story. And that is where the nuances start to appear because you have to keep balancing speed with quality. It's not enough to build something that works. It's something that needs to be sustained and have quality outputs, and you have to have evaluations to check for that. Because nowadays with non-deterministic systems, what happens is that you can call an LLM and put it there, but how do you ensure that it's doing what you want it to be doing and that it's actually bringing quality is what breaches how do you automate the best out of it while maintaining control of the actual outcomes of a non-deterministic system? How do you make it flexible so it can be easily changed while maintaining safety and guardrails to ensure that there are no risks associated with it? That is where the problems start and begin. So I will say that I think the AI evolution is here. I don't think that it's something that we can deny. How we use AI, it's up to us and up to the different companies. In our case, we want to provide to anyone at the company the tools to be AI native and to use AI in day-to-day basis. That has helped immensely internally in terms of how we are more productive, in how we have more speed, how we connect the dots better. Notion AI, it's one of my best friends right now. That's the reality of it, right? But then we have to also be mindful of we are, apart from using it internally, we are building external products using AI. That means that we have to embrace a change in how we are building things. For instance, evaluations, evals is not something optional. We don't have unit testing anymore because the code is no longer providing deterministic outcomes. You cannot, like, customers and people in general are extremely creative. You put together a AI system and you expect people to use it in a way, they are going to surprise you, I assure you. So having evaluations in place, constant observability, so you keep iterating over and over again, so you have clear ways to trace how the customers are using the product, what kind of outcomes that product is giving. Is that something that it's useful for them or not? Is providing the quality that you expect to have? All of that is the type of pipelines that we need to be building from now on.
Yeah. Evals are so important indeed. And with the advance of AI, there have been more and more frameworks, the software frameworks that AI engineers and engineers in general have been using to build stuff. Do you have any favorite frameworks that you really like? Well, if you're open to sharing some that you don't like,
The first time that we started building AI features, I think was like 2 years ago, something like that. It was like we were pioneers in that area. We built our own evals pipelines internally. We built everything using, I think it was OpenAI library called evals. and we built our whole library internally to be able to do the evaluations. But one of the things that we've seen is that that doesn't quite scale, right? You need to provide the product teams a way to do evaluations at scale and to have a clear observability inside the different features that they are building for development, but also in production. So you need different levels and different components as well. So quite recently, we ended up procuring Arise AI, it's called, as a product for the whole company to use. So that's where we have been building all of our observability pipelines, where all the traces are sent, and we can have, with a very secure environment, we can analyze and iterate on how the customers are using the feature. We can provide the monitoring needed in order to ensure that the quality of our output is there, and all the evaluations and guardrails. So we constantly keep iterating on them. So it's not part of the research bit or part of the development bit. It's something that you have to incorporate as part of the UX, actually.
Yeah, exactly. It has to go all the way through the data, through the backend to the final UX and UI. Yeah. It's and it's changing, I think, the way software engineering works. Now you can have, you don't have. Well, it's better to have more general software engineers who know about many different things, maybe front end data engineering, rather than having someone who is a specialist in some small niche topic like training XGBoost models and optimizing the hyperparameters.
Yeah, that would very much depend on the company, right? Maybe you have a company that really needs someone that is capable of giving that 1% extra accuracy in that model. But for many other companies, especially SaaS companies, I will say what you need is people that have ownership and people that has the ability to learn and to have the right attitude, more than these very niche technical skills. Which again, if you put me to code front end, that will be a huge drama, right? Like I will not be able to do that. So no matter how much willing I have, but I think matching that kind of skills with attitude, it's important. And also I think when people start working on these, on data science or machine learning, they need to have a little bit of overview of everything, because it's important to have that end-to-end view. For instance, many companies have a very strong distinction between data scientists and machine learning engineers. In my opinion, they are both part of like two sides of the same coin. It's not like a data scientist can just build the model on a notebook and just send it over the machine learning engineers to actually put it in production. You need to understand end to end what that is bringing, because otherwise you have people doing research and building POCs that are super away from the actual production, like how that data is going to be used. And on the other hand, you've got amazing engineers building pipelines without knowing how they are going to be used. So you need to connect the whole end to end. And the same happens with AI features, right? Like the collaboration between the different teams. You have the design team, you have the front end, the back end, you had the AI engineering teams, all of that, the product managers, like it's all part of the same machinery. So you have to create the space and the frameworks for all of these people to work together and ensure that they can deliver at a very high pace, but with a very clear definition on how to collaborate.
Yeah, and speaking of end-to-end, we've touched upon this a little bit, but of course the final result of the end-to-end should be some value delivered to the customer, or perhaps some revenue generated to the company. How do you make sure, especially at your level, leading the data functions, how do you make sure that there are actually specific goals, maybe like KPIs or OKRs, that are visible and tracked so that you can actually measure the real value that is added by the data people?
The way that I see it, anything that you build, when you start thinking about it, you need to think as a part of that, ideation, how this is going to be measured. What you don't measure, it doesn't exist. So if you cannot prove the value, if you cannot really tell, either ideally you're going to be able to say that in a dollar unit, right? So, or a money unit, or whatever currency you have. But to put an actual value of, I have in general in data science / machine learning, because it's the same, AI, whatever. There are 3 pillars where we can act on. The first one is to provide direct revenue. You can just build something that gives you money. The second one is a way to save money to the company, right? To prevent from spending more money. And the third one is through risk, lowering the risk for the company, so it won't have potential problems in the future. If you are able to connect your work to one of these 3 pillars and to explain that to the business and providing an actual value of how many dollars you are saving, or how many revenue you have came from that particular model, or how much you have decreased the risk of having hallucinations, blah, blah, whatever, that is the actual value. That is the value that you need to provide. And you need to think about all of these things at deviation when you start thinking about what are we going to build. So it's not about technical feasibility. It's technical, like, what is the problem? I love to have this. I'm a big fan of Simon Sinek, by the way. The power of the golden circle, right? The power of why. Start with the why, and then the what, and then the how. And as part of that exercise of trying to explain very clearly what is the problem that you are solving, why it's important, and how are you going to solve it, you need to also encompass how are you going to measure it.
Yeah, I 100% agree. To just stay on this topic a little bit more, whose job do you think it is to kind of to make it clear what exactly value you're delivering? Is it the go of the data scientist, or the software engineer, or the product person, or the director of the division?
To be honest, if we have ownership, it should be all of us thinking about that. Because all of us will have different ways of measuring that, or different approaches to that. But even you need, as an individual contributor, you need to be aware of how much value you're bringing to the company. And it should be also part of your responsibility to ensure that that is being measured. From a product perspective, when PMs design, I do believe that also part of the role is to ensure that they are measuring that, because that's how you tell the story. As a director or as a leader, it's my job to measure that, to ensure that I can provide a value to my function. How many data teams we've seen that they are just cost centers? The moment that there is some financial problems, you get rid of the teams that cannot put a value on, right? There's not bringing revenue. But if you do a good job at measuring how much value you're bringing, that should not be part of the conversation, because that's implicit already. You are already providing that value up front. So I do think there is not an only owner about that. It should be everyone's problem, and everyone's is responsible to ensuring that you can provide the value of how much impact you're having. Do not expect others to do something for you, in the sense of, if you can provide that value, just do it.
Yeah, and that goes back to giving people ownership and the ability to own problems end to end, and to be responsible for everything around it.
And many times you're gonna find situations where an individual contributor doesn't know how to do that, right? It's common. We've a few years ago, you will ask me, how much revenue have you bring to the company? I will be like, we don't know. I've got no idea how to even calculate that. So it's a great way when you start thinking about it. If you show people how to do it, if you ensure that people are also empowered to do it, and you invite them to be part of those conversations, that is also useful. You need to also, part of our role as leaders is to mentor people and to coach people and to make them learn. The same that happens when you have a more junior individual contributor, that you need to show how to do stuff, but also point at things that technically they need to keep learning and iterating on. When they keep growing and maturing to more senior positions, you have to then coach them on how to prioritize. What are the things that they have to delegate? What is they have to build a prioritization matrix, and they need to understand how much for measuring efforts, capacity planning. All of these things are also important to coach. The same goes for measuring impact. That's not something that we learn at the university, right? That's something you keep building on, and you need someone to show you how that's done.
Yeah, good stuff, especially on this topic on the business impact. I think that nowadays still a lot of companies are making decisions based on, for instance, decisions on what product to build on some sort of a whim or a feeling, or one customer said something, and it should be a little bit more data-based than this and a bit more factual.
I love that, because sometimes we might feel that we are building by vibing, right? I've got the vibe, I've got the feeling of just let's measure things. Let's make sure that we can put numbers into things so we can take informed decisions. And that's especially important when working with AI, because what it might feel like, this is how the systems is behaving. You need to actually check, because you don't know. Quite literally now you don't know, right? So it's so important to have this observability in place so you can actually validate those assumptions that people are using these systems in this way. When you look at the data, then you can validate that hypothesis or disregard it, because maybe not. A/B testing, exactly the same with A/B testing. A/B testing should be wired in the DNA of the software companies, because this is how you validate and prove things and keep iterating on. Quick iterations, but fast iterations as well.
Okay, great stuff. I think we covered a lot of interesting topics. Is there anything that perhaps you wanted us to chat about and we didn't have the opportunity to talk about?
Yeah, sure. I think we covered a lot of very interesting topics, and there is always more room to do. But I will say that, just to finish up a little bit, but I feel that many people are trying to get into the AI space nowadays, or the machine learning space. I think it's important they need to understand what they are doing. Understanding the underlying concepts is important. And also making sure that they are solving actual problems, like end-to-end problems and real-world scenario problems. That is also very important as well. So I will say that if you really want to land a job, just quit the hype and build a portfolio of things that actually matter, that can, that are real-world things. Just show it, because everyone is looking for people that can really provide value to the company.
Yeah. Nice. I like this advice. And is there any specific place where people can follow you, or perhaps where people can follow Typeform, or anything else that you want to plug in at the end?
Yeah, we've got, I would say LinkedIn is the best place to find people around, either companies or people in general. I am not super active, I'm going to say, like, I'm not the best one to showing and providing advice or anything, but I'm always happy to if you want to ping me, if you want to chat, I'm always available for that. So yeah, I would say LinkedIn is the best place to do so. Nice,
amazing. Well, I really enjoyed our conversation, Carmen. Thanks again for being on the podcast, and I'll see you around. And for our listeners, until next time.
Thank you so much for having me, Yawor. Have a lovely afternoon. Thank you all for listening. Bye.
Thank you. Thanks for listening to the AI and ML conversations with myself, Yawor Botev. If you want to support the show, please subscribe to the podcast on YouTube. In addition, please follow the podcast on Spotify and Apple, and share it with the people you know. Thank you.